Dad, I want you to read the words on the list. Pick out your
Bam,
faves.
lit, Gucci, turn up, boy, bro, boogie.
Yeah, okay. Read specific ones. Read this one. Wait. This one.
Bay.
Okay, read
What about that first one?
this one.
Beefing.
Okay, hang on. Okay, tell everyone to like and subscribe my YouTube channel.
Like and subscribe to Chris's YouTube channel.
There you go. Here, we're going to talk about graphing in standard form. So there's a variety of things that we can do to graph in standard form. First thing we can do is we can look at the y-intercept here, okay, which is -5. We see that on the equation here. That is our y-intercept. Now the next thing we're going to do is we're trying to find the vertex and the axis of symmetry. So the y-intercept is 0, -5, okay? So to find the vertex and the axis of symmetry, we need to use this little equation, (b/2a). The b here is 6, so it's -6. The a is -1, so it's 2 times -1. We divide this and multiply, we get 3. That is the line for our axis of symmetry. It's also the x value for our vertex. So let's do this. Okay? Make that clear. You need to make sure you draw that axis of symmetry, but I'm gonna make that much clearer with highlighter, okay? And the vertex, we find the vertex by plugging the 3 back in. To our equation to find the y value for the vertex. So again, the equation for the axis of symmetry was x equals 3. Now we're trying to find the value for the vertex. So that becomes -9, because 3 squared first, and then multiply by -1, plus 18, minus 5. So y equals 4. Okay, that means the vertex is 3, 4. Okay, so since quadratic functions are symmetrical, we can just take this point and reflect it. So it's 1, 2, 3 away. I'm gonna go 1, 2, 3 the other way. I'm gonna connect to my points. And there's my graph for the quadratic function. Okay. Now let's move on to doing this in the other form. All right, let's look at the vertex form. Here, we need to go through a variety of transformations, but right off the bat, we know the vertex based on our equation. The vertex is -2, -5. So I can go ahead and plot that, -2, -5. The question though is how to graph the actual graph. So you need to use the OG, which is y equals x squared. And using what we learned about transformations, you can transform this to get to the graph we're trying to make. So first thing I see in terms of steps is I need to do the subtract 2 from the x. We're doing the horizontal translation. So that means I get x -4, -3, -2, -3. Oh, sorry, not -3. -1, 0. The y values don't change. Next thing I need to do is need to multiply the y values by -1/2. So I get x. I get -4. The x values didn't change. So I get -2, -1/2, 0, negative 1/2, negative 2. And the last step we need to do is we need to subtract 5 from the y values. So again, the x values didn't change again. Okay, then I get negative 7, negative 5.5, negative 5, negative 5.5, negative 7, okay? So the graph I'm gonna make, all right, we go negative 4, negative 7, negative 3, negative 5.5, vertex, and then 0, negative 7, okay? So it looks kind of like that. It's really important. I almost forgot a very important thing to do on my graph here. I also know that the axis of symmetry is x equals negative 2. Okay, and there you have it. The last form that we're going to look at is factored or intercept form. They both have the same names. Okay, so what we're going to do to look at that is we're going to look at our x-intercept. So based on this, I'm looking at the opposite. So here I can read this and see that the x-intercept is 5 and 1. Okay? Now, I know that the vertex is halfway between these two, so I know that the vertex has to be right here at 3. Okay? So if the axis of symmetry has an equation of x equals 3, I can use that to find the vertex by plugging that value back into the equation. So y equals 2 times 3 minus 5, and 3 minus 1. Y equals 2 times negative 2, and then 2. So y equals negative 8. So the vertex is 3, negative 8. 3, negative 8. Looks kind of like that. There you have it. Now what if we were given the graph? Okay, so if we're given the graph, we could use this graph to try to identify the standard form, the vertex, and the intercept. Okay, so I know that the standard form, I have to use the vertex and the intercept to get to the standard form. So we'll use, so the vertex form is y equals, the vertex is negative 5, negative 8, so it's x plus 5 squared minus 8, and the intercept form is y equals x plus 7, and then x plus 3. So I can use this intercept form to find the standard and multiply them. I'm going to do that over here. So it's x plus 7, x plus 3. This is x squared. This is 7x. This is 3x. This is 21. So it means our standard form is y equals x squared plus 10x plus 21. Okay? The question, though, is or has there been something multiplied on these? That's the question. Okay? So in order to do that, we have to pick a point on our graph and plug it in. So I'm going to pick the point right here. And that point is negative 4, negative 6. I'm going to plug in negative 4. I'm going to plug in the point negative 4. negative 6 into my equation. So, does it matter which one I plug it into? No. I'm going to try the, let's do the vertex form. So negative 6 equals a times negative 4 plus 5 squared minus 8. So I'm going to do parentheses first. I get negative 6 equals a times 1 squared minus 8. Negative 6 equals a, because 1 squared is just 1, minus 8. Add 8 to both sides. I know that a equals 2. So our real final equations are 2 here, 2 here, and 2 there. The only one I can really simplify is this one, so I could get 2x squared plus 20x plus 42. Otherwise, the rest of them have already been simplified. But that's how you do it. You gotta pick a point on the graph. It cannot be any of these key points. Okay? And there you have it.